Hi everybody, I wanted to talk about section 10.3 on hypothesis tests for a population mean. So those would be our objectives: to test a hypothesis about a mean, understand the difference between statistical significance and practical significance. So objective 1, we want to test the hypothesis about a mean. So to test hypothesis regarding the population mean, assuming the population standard deviation is unknown, we will use the t distribution in this case rather than the z distribution. So when we replace s and sigma with the appropriate values, we'll get this equation, and this follows students' t distribution with n minus 1 degrees of freedom. So the properties of the t distribution are that, again, the t distribution is different for different degrees of freedom, and the t distribution is centered around 0 and it's symmetric, unlike the chi-squared distribution. And the area under the curve is 1, just like any probability distribution. So as t increases or decreases without bound, the graph approaches but never equals 0, just like the standard normal distribution. The area in the tails of the t distribution is a little greater than the area in the tails of the standard normal distribution, because using s as an estimate of sigma introduces more variability into the t distribution. And so basically everything that we covered in section 9.2. And then as the sample size n increases, the t distribution will get closer and closer to the standard normal distribution by the law of large numbers. So testing hypotheses regarding a population mean, to test this, we have to make sure the following things hold: that the sample is obtained using a simple random sample, that the sample has no outliers, and that the sample size is greater than or equal to 30. And then the sample values are independent of each other. So again, there are three outcomes that can happen in this case, depending on the particular type of situation we have. And again, all the steps here are listed on the bottom of page 497, the first section in section 10.3, and continue on to the bottom of page 498. And then so we need to select the level of significance. Again, unless otherwise stated, alpha will be 5, same as in section 10.2. Alpha will be 5%. So we go ahead and calculate the test statistic. So notice this is slightly different than the test statistic computed in 10.2 for the normal distribution of the z-score, but it's very similar. And then again, we have two different ways we can evaluate this. We can use table 5 to determine the critical value, or we can also use the classical approach, just like in section 10.2, to compute the probabilities. And again, either use table 6 to approximate the p-value, or if you need something a little bit more accurate, you can use StatCrunch or something like that. And then if the p-value is less than the alpha value, for the p-value approach, again, you reject the null hypothesis just as before. And then don't forget to state the conclusion, right? So don't forget that once you've determined whether the null hypothesis is true or not, you actually state in words what the conclusion is. So this procedure is robust, which means that minor departures from normality will not adversely affect the results of the test. However, for small samples, if the data has no outliers, the procedure should not be used, and we'll have to rely on parametric tests, which are talked about in chapter 15. So as an example, let's assume that the resting metabolic rate of healthy males is about 5,710 kilojoules per day, and researchers measured the RMR of 45 healthy males and found that their resting metabolic rate to be this, with a standard deviation given by this. At the alpha equals 0.05 level of significance, so if alpha is equal to 5%, is there evidence to conclude that the RMR for males listening to calm music is different from this value. So again, we want to use a t-statistic in this case. So, and again, will be a two-tailed test since we're trying to determine if it's different from this. So go ahead and calculate your t-statistic. This would be the null hypothesis and the alternative hypothesis. Keep in mind your level of significance. So the sample mean is given by this, S is given by this, so throwing into the formula gives you a t-value of this. So using the classical approach with 44 degrees of freedom at an alpha equals 0.05 level of significance, our value would be this. And since the test statistic, the one that we calculated, is between the critical values, we will fail to reject the null hypothesis in this case. If you decide to use the p-value approach, again, you can calculate the probability corresponding to the t-value. So the probability that t is less than this plus the probability that t is greater than this is less than 0.05, which is less than your p-value. And so since the p-value is greater than the level of significance, again, we will not reject the null hypothesis. And so to state this in words, right, there is insufficient evidence to conclude that the RMR of males listening to calm music differs from this amount. So it's essentially the same. As another example, let's do an example where we actually have the original data. So according to the United States Mint, quarters weigh about 5.67 grams. So researchers interested in determining whether state quarters have a weight that is different from this value. So the person weighs 18 randomly selected quarters, and so the question is there evidence to conclude that the state quarters have a weight different from the mean weight, which is 5.67 grams? So since the sample size is small, we must verify that the data comes from a population that is normally distributed with no outliers. Again, this goes back to something we talked about in a previous chapter. Again, I'm not going to have you guys calculate these QQ plots. I will either just say that the data is normal or give you the plot here. So again, the null hypothesis in this case would be that mu is equal to 5.67. And then the alternative hypothesis would be that there's some difference, so this will be a two-tailed test at this level of significance. In this case, I'm not going to go through the procedure for computing the mean and the standard deviation, but here they are. Throw this into your test statistic would give you 2.75. So again, using the classical approach, the alpha level is 0.05. This is a two-tailed test, so you'd want to divide that by 2. So the two t-values would be this. The calculated t-statistic is this. And so this is greater than the critical value of 2.11. So our test statistic is in the critical region. It's further to the right than the right value of the test here. So we will reject the null hypothesis. Using a p-value approach instead, again, you should get the same answer either way, but using a p-value approach in this case, the probability that t is less than negative 2.75 or greater than 2.75 is quite small. That will give you, so the p-value in this case will be between 0.01 and 0.02. Again, you could use StatCrunch to find the exact value, but all we need to do is compare that to the alpha level, which is 0.05, and since the p-value has to be less than 0.02, it also has to be less than 0.05, so we will reject the null hypothesis. So stating the conclusion then, there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that the mean weight of the state quarters differs from 5.67 grams. And again, on the exam or the homework, it doesn't really matter to me if you state the level of significance, right? That hopefully that will be clear from the problem. But you know, in a research journal or something, you might want to make it extra clear what level of significance you are referring to, because that will make a difference in how people will interpret the answer. So objective 5 is to distinguish between statistical significance and practical significance. So when large sample size is used in a hypothesis test, the result could be statistically significant, even though the difference between the sample statistic and the mean stated in the null hypothesis, there may be no practical significance, or there might be a statistically significant difference, but maybe practically you couldn't implement the change because it would be too costly or something like that. So just be aware that just because something is statistically significant doesn't necessarily mean it's practically significant. So practical significance refers to the idea that, while small differences between the statistic and parameters stated in the null hypothesis are statistically significant, the difference may not be large enough to cause concern or to be considered important. Or, again, there may be nothing you can do about it. So as an example, let's say in 2003, the average age of a mother at the time of her first childbirth was 25.2. To determine if the average age is increased, a random sample of 1,200 mothers is taken, and it's found that that they have a sample mean of 25.5 with a standard deviation of 4.8. Determine whether the mean age has increased using a significance level of 0.05. So again, setting up the null and alternative hypothesis, calculate the test statistic. We've already done this example, so we calculated the mean before. So again, since this is a right-tailed test, we'll just use the p-value approach in this case. So the probability that t is greater than 2.17 gives you a p-value between 0.01 and 0.02. Again, you could calculate this exactly using StatCrunch, but all we need is enough to compare it to the alpha level, which is 0.05. And so in this case, because the p-value is less than 0.02, which would also be less than 0.05, we can reject the null hypothesis. So the conclusion then is that there is sufficient evidence at the 0.05 level of significance to conclude that the mean age of a mother at the time of her first childbirth is greater than 25.2. So this comes back to the idea of practical significance, right? Although we found that the difference in age is significant, there really is no practical difference between the ages, right, of 25.2 and 25.5. And again, whether that would be a cause for concern or not, I guess it depends on what you're trying to study in particular. So again, just because there is a statistical significance does not mean that there is a practical significance between these two values. One of the other things we want to talk about here is large sample size. Remember that large sample sizes can lead to statistically significant results, while the differences between the statistic and the parameter may not be enough to be considered practically significant. Right, well that wraps up section 10.3. So the next section we'll look at is section 10.4 on a hypothesis test for population standard deviation. Oh man, when did this pause? Oh, I see. As soon as I exit the PowerPoint, pause. That's interesting.